Hello everybody, welcome you all. I am Karthik Gupta. Today we are going to discuss the topic pipes and cisterns. Okay, a similar topic related to time and work, but it's an important topic. Because of that reason we have bifurcated this one as a separate module. Okay, so pipes and cisterns. Whatever the concepts we have discussed in the time and work, the same concepts are applied here also. Okay, the time is inversely proportional to efficiency and the efficiency is inversely proportional to time. But the type of problem what they are going to ask is a bit different, and for few problems we have to look the problem in a different perspective. Okay, so pipes and cisterns. Let me take an example. In the pipes and cisterns, for example, you have a syntax. You have a syntax. You have a syntax. A syntax is having an inlet. A syntax is having an inlet. Which takes 1 hour to fill the tank. Okay, a syntax or a tank which takes 1 hour to fill the tank. Now one more inlet which takes 2 hours to fill the tank. Now if both the inlets are opened simultaneously, then how much time it takes to fill the tank? This is a variety. Consider it as A. Next, see here, one more syntax or one more tank. So here one inlet which takes 1 hour to fill the tank, and one more inlet which takes 2 hours to empty the tank. Okay, one inlet which takes 1 hour to fill the tank and one more inlet which takes 2 hours to empty the tank. Now how much time it takes to fill the tank? That is variety B. Okay, how much time it takes to fill the tank? Next, one more variety. Again a syntax. Okay, two outlets are there. This outlet take 1 hour to empty the tank and this outlet take 2 hours to empty the tank. Then how much time it takes to empty the whole tank or whole syntax? So this is a third variety. These are the three basic varieties what we can see in the pipes and cisterns. One thing you have to remember and one thing you have to observe, that whether the work what the inlets and outlets are doing, whether the inlets are doing the positive work or the negative work, or the same nature of work both the inlets and outlets are doing, or the opposite nature of the work both the inlets and outlets are doing. See here, in the variety A, both the inlets are used to fill the tank. So the nature of both the inlets are same. So if the nature are same, then we have to add. And in the second case, one inlet is used to fill the tank and one more inlet is used to empty the tank. See here, one inlet used to fill the tank, one more inlet used to empty the tank. Means the nature of their job is different. If the nature is different, then what we have to do? We have to subtract. One thing always you have to remember, if the nature of the job is same, then you have to add. If the nature of the job is different, then you have to subtract. See, the third variety, both the inlets are used to empty the tank. So here, the nature of the job is again same. Whether it may be filling or it may be emptying the tank, it doesn't matter. Okay, it may fill the tank or it may empty the tank, it doesn't matter. Only the thing is the nature of the job matters. Whether both the inlets are doing the same job or different job. Here, both the inlets are doing the same job, both are emptying the tank. So how much time it takes to empty the tank? Again, the nature is same, then we have to add. So very simple thing, very simple thing. See here, very simple. Consider the variety A. Consider the variety A. One inlet, it taking 1 hour. Another inlet, it is going to take 2 hours. So according to the time and work concept, with the help of LCM, if we calculate, we are going to get the answer very soon. Okay. So what is the LCM of 1 and 2? The LCM of 1 and 2 is 2. So 1 times and 2 times. So now how much time it is going to take? 2 divided by 2 plus 1, that is 2 by 3 hours. 2 by 3 hours. So very simple thing. In the second case, again 1 hour and 2 hour. What is the LCM? 2 is the LCM. So now 2 times 2 1 times. So 2 divided by, see here, in the case B, both are doing the different types of job. One inlet is filling the tank and the another inlet is emptying the tank. Means both are doing different job. If they are doing different job, we have to subtract. So divided by 2 minus 1. So that is 2 by 1, that is 2 hours. That is 2 hours. So next, in the case 3, again 1 hour, 2 hour. What is the LCM? 2 is the LCM. So now 1, 2 times 2, 1 time. Next, LCM divided by, now what about the nature of the job? The nature of the job is same. If the nature of job is same, then what we have to do? We have to add their values. Okay. So divided by 2 plus 1. See here, this 2 we have to consider and this one we have to consider, which is equal to 2 by 3 hours, which is equal to 2 by 3 hours. So the first case, 2 by 3 hours, it is used to fill the tank. Second case, 2 hours it takes to empty the tank, and third case, again it takes 2 by 3 hours to empty the tank. Okay. So if you remember these three concepts, then you can solve most of the problems. This is the foundation for pipes and cisterns problems. Okay. So next, let me give you one more example. See here, an important variety. A tank is there, and 2 inlets are there, The bottom inlets take 1 hour, takes 1 hour to empty the tank, and the upper inlet take 2 hours to fill the tank. Okay. So the bottom part, that inlet takes 1 hour to empty the tank, and the upper part inlet takes 2 hours to empty the tank. Then how much time it takes to fill the tank? Okay. So see here, the question says, okay, how much time to fill? So this is the question, how much time to fill? So you properly observe the diagram, the upper part 2 hours and the bottom part 1 hour. So how much time it takes to fill? So see here, the speed of the outlet is more than the speed of the inlet. See, the outlet tap is taking only 1 hour to empty, but the upper part it is taking 2 hours to fill. Means the speed of the upper inlet is very less compared to the speed of the outlet. Means what? Okay, outgoing water is more when compared to the incoming water. Means it is not able to fill the tank. Okay, it cannot fill the tank. Properly you have to observe the question, how much time it takes to fill? It never fills. Because the outlet speed is more than the inlet speed. Okay, if the outlet speed is more, then how it can be filled? So it cannot be filled. But if they ask you the question like this, how much time to empty? So how much time it takes to empty the tank if it is filled? And the bottom part, it takes 1 hour to empty the tank, and the upper part, it takes 2 hours to fill the tank. If both the taps are open simultaneously, then how much time it takes to empty the tank? Definitely it is going to become empty, because the speed of the outlet is more than the speed of the inlet. So definitely it is going to get empty. So you have to be very, very careful regarding the type of the questions what they are going to ask. So always you have to remember this concept, okay, and you have to attend the questions carefully. So we have discussed all the 4 varieties, the important varieties, the basic concepts of the pipe and cisterns. When you have to add, when you have to subtract, in what perspective they are going to ask the question, so how you have to analyze the questions. So these things we have learnt now. Okay, so very simple thing, we have to use the concept of time and work only. Okay, we have to use the concept of time and work only. Okay, fine. So these are the basics. You have to understand the basics and you have to move on to the problems. Okay, let's move on to the problems. Problem number 1. 2 pipes A and B can fill a tank in 18 hours and 6 hours respectively. If both the pipes are opened simultaneously, how much time will be taken to fill the tank? See here, the nature of the job is same. 2 pipes can fill a tank in 18 hours and 6 hours, means the nature of the job is same. Okay, so if both the pipes are opened simultaneously, how much time will be taken? How much time will be taken to fill the tank? How much time will be taken to fill the tank? See here, the nature of the job is same. If the nature of the job is same, then we have to add. That is the indication. So 18 hours and 6 hours. 18 hours and 6 hours. What is the LCM? 18 is the LCM. So 18 1 times, 6 3 times. So 18 divided by 4. 18 divided by 4, that is 4 4s are 16, 4 5s are 20. Your answer is 4.5 hours. Your answer is 4.5 hours. Very simple to calculate. Why we have to take LCM? All those things in the time and work we have explained in detail. Okay. So let me move on to the next problem. Problem number 2. Problem number 2. A cistern can be filled up in 4 hours by inlet A. An outlet B can empty the cistern in 8 hours. If both inlets A and B are opened simultaneously, then after how much time will cistern get filled? See, one thing we have to observe properly, the inlet which is used to fill the tank, the time taken by the inlet which is used to fill the tank is 4 hours. The time taken by the inlet to empty the tank is 8 hours. Means filling time is less than the emptying time. Means the speed of filling the tank is more than the speed of emptying the tank. If that is the case, then definitely it is going to be filled. If it is not that case, then it can never be filled. So here the speed of filling the tank is more than the speed of emptying the tank. So at the end of the day, definitely it will be filled. Okay, so see here, 4 hours it takes to fill the tank, 8 hours it takes to empty the tank. The LCM is 8, so 8 1 times, so 4 2 times. So 8 divided by, so see here the nature of the work, one is used to fill and another one is used to empty. So if the nature of the work are different, then what we have to do? We have to subtract. So 2 minus 1, so which is equal to 8 by 1, so 8 hours. So 8 hours, option C is the right answer.